the first of the P2 podcasts, and this is on static electricity. Okay, quite a big chunk on static electricity, but there is a significant amount of overlap from chemistry and the different parts of physics as well. So, and what I mean by that is a starting point, and the starting point is to understand the structure of the atom in order to understand what on earth is going on in static electricity. So we have got this atom. If we break things down to its smallest unit, you will end up with an atom. And in the atom, I'm just going to draw a very simple atom. You've got things that live in the nucleus and things that live outside the nucleus. Right, okay. Now, we have got these three different particles. We've got an electron flying around the outside of that nucleus. And we've got a proton. And lastly, we've got a neutron. Now, in certain circumstances, these electrons have a tendency to go off somewhere else for a happier life with a different element or a different kind of material. So we need to bear that in mind. But the most important thing to bear in mind about the structure of the atom is the charge and their mass. So we can draw ourselves a little table. And if we write particle here, we can have proton, neutron, electron. Charge, and you've got positive charge, zero charge, positive, no charge, and E is a negative charge. And then we can say that the mass, now protons and neutrons are the same size relatively, and they've got 1, a mass of 1. The electrons are so tiny that we can call them 0. It is actually 0.0000098, but we can just call them 0. Now, you should have a ruler. I haven't got a ruler, so I'll tell myself off for this. If you want to make your notes as neat as possible, you should use a ruler. Okay. Right, so that's the background information we need to know. I'm going to refer back to electrons. I'm going to refer back to their charge. So if you are stuck on this, then you need to keep revising this part. And like I said, again, this comes up when we talk about radioactivity for physics and also for basic chemistry knowledge. So let's move on. So what is static electricity? How is it built up? And the easiest way to describe it is using a diagram. Now, if you have two, we'll write it somewhere actually how to do this as I'm thinking out loud. We'll write a keywords box here. Keywords. Keyword number 1, insulator. Doesn't conduct electricity, doesn't let electricity through. Things like rubber, things like plastic, things like cloth. Okay? So, if you have two insulators, let's say we had a cloth and a rod, which is what we used in lesson. Now, to start off, they are neutral because we've got equal number of electrons and protons. So we'll have 3 on there and 3 on there. Right, so in their normal lives, without being interfered with whatsoever, you've got 3 pluses and 3 negatives. Now, if you start to rub these insulators together, causing friction, keyword box, friction. If they are rubbed together, and this is a before diagram, and this is an after diagram, the electrons will be rubbed off from one to another because they're flying around the outside and they can easily transfer from one to another. So they are transferred from one to another. You will know by exam question which way they have gone. So let's say they've gone from the cloth. The positives cannot move. They're there in the nucleus. They're not going anywhere. So the electrons move. So the positives stay the same in the rod also. But this time, those 3 electrons that used to be with the cloth are now on this rod. So 6. So you've got 6 negatives and 3 positives. So this is now negatively charged. Sometimes you'll just see the word charged. So our rod is charged. Okay, it's going round charged. So if you then get this rod that you've charged up, 1, 2, 3, 1, 2, 3, 4, 5, 6, and you bring it close, I don't know, to some little bits of paper like we did in the lesson. As you bring that close, the negative in this piece of paper will go as far away as possible. Same in this piece of paper. The negative will move far away as possible. And the negative will move far away as possible because they are repelled. I'll do the diagram in a second. And this is static electricity, inducing a charge. So insulator, friction, electrons transfer and to cause a charged object. So let's draw another little diagram to understand what's going on. If you have positive, negative, they are going to go towards each other. That's going to go that way. That's going to go that way. They attract. Positive, positive. They are going to go that way from each other. They do not like each other. They repel. Same with a negative and a negative. They also repel. Okay? So we're building this picture for static electricity. The foundation, how you induce it. What happens when different charges come in contact with each other. The last thing is, you've got some uses of static electricity, but also some dangers. So uses, things like a spray can, excuse my drawings. There we go. Spray paint. Now if you plug this in and charge the paint in there, so every single droplet becomes charged negatively. Every single droplet becomes charged. And let's say you're sticking this to one exam question said a piece of metal. And they charge this positively. They put positive charges on this. What's the advantage of this? Well, it's twofold. First thing, when these droplets come out, they're all negative. So they're going to want to get as far away from each other as possible. And what this causes is a nice even spread of paint. Not just all in one clump coming out like this. That's not going to happen, no. What is going to happen, it's going to even spread. And if you charge the thing that you want your paint on, at the opposite charge, then opposites attract and the paint will stick to the metal. Brilliant. So that's some uses. They might give you an example that I've not taught you in your examination. You've got to apply your knowledge. Think, where the negatives, where the positives, are they going to stick or not? Lastly, dangers. There are dangers because, for instance, if you have an aeroplane, my very bad aeroplane, in the sky, and it's rubbing with the clouds because it's not earthed, even though it's metal, because it's not touching the floor, those negatives can't go anywhere. So it may pick up lots of charge. So it becomes charged, the plane does charge. Do you remember? Charge means an excess of negatives. So when this plane gets refueled by the tanker, this is Shell petrol, there is a danger when this hose comes in. These negatives jump. And if they jump, they could cause a spark. Key word. If they cause a spark, you could have an explosion. Okay, so how do you get rid of this? But the way you get rid of excess charge in any situation, how do you get rid of all these extra negatives? Well, you need to put a small wire called an earthing wire. And an earthing wire will be attached to the plane, or whatever you're talking about, and all these negatives will run off. Negative, 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 and they'll go back down to earth. Negative, 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 until you've got an even balance. So all the excess charge goes away down the earth wire, because that is a conductor. So any metal will do. So it will conduct the electric charge down there, because you don't want this explosion happening. Okay, I think that is static electricity done and dusted. Let's have a look at some exam questions.